This is the video for Chapter 1, Lesson 3, Describing Quantitative Data with Numbers. And really what we want to focus on is the question right here. What are the different measures of center and spread we can use to analyze the distribution, and then when is it yet best to use each and why? So the second question is really important here as far as getting an understanding of what each is telling us and how each is affected by things like skewed distribution. And then knowing if there is skew, what will give me a better idea of where most of the data is. So let's talk about our measures of center. One measure of center is mean. You can think about this as the balancing point on a curve. If you put a small triangle under the curve, it's where the curve would balance perfectly. So that means if you think back, or if you've taken physics, torque increases. Something that's far away from the middle puts more force on something. So an outlier has more effect on the mean. So putting one outlier way away from the rest of the distribution changes where the balance point would be. Just like if you stood really close on the seesaw and your friend stood really far away, they would be pulling down with more force, more torque on the seesaw. So that's the idea there. It's the balance point. We use x bar for the sample mean and mu to represent the population mean. Population is generally what we're trying to find out with a statistical question, like who will be elected the next president. So we take a sample that we think is representative and try to use it in order to answer that question about the population. We'll talk more about that as we move forward in Chapter 4 especially. So use a measure of center. We use mean with uniform, symmetrical, and roughly symmetrical distributions. Remember, uniform was kind of like that flat line. Symmetrical means there's a mirror image left and right. So mean is a good measure then. If something's perfectly symmetrical or perfectly uniform, then the mean and the median are equal. So in my mind, that kind of begs the question, well, why don't I just always use the median? Well, the mean and standard deviation are going to let us do a lot of cool things as far as determining how likely an outcome is to occur by chance. So as we go on, we'll see why we would use the mean. Just for now, you need to know that if there's symmetry or approximate symmetry, or if there's a uniform distribution, we can use the mean. If we have skew, we use the median. So the median is the midpoint of the distribution. So half of the numbers are larger and half are smaller. That also means it's there at the 50th percentile. It's there in the very middle. If I have seven observations, it would be the fourth, because 3 are less than it and 3 are greater than it. So we arrange them from least to greatest. If the number of observations is odd, it's the middle number. If the number of observations is even, the median is the average of the two middle numbers. So I would take the two numbers in the middle. So if I have 6 numbers, I would take the third and the fourth, and I would add them up and divide by 2 to take their average. Whenever there is skew, we use the median because it is not affected by outliers. It's still, whether my outlier could be 10 times as big to change its value, it doesn't affect the median because it's just the middle number. So whenever there's skew, you want to use the median. For that same reason, we'd use the IQR, which we're going to talk about in a little bit when there's skew. So the median and the IQR, which is the interquartile range, are what we're using when there's skew. If they're roughly symmetric distributions, they're close together. If there's slight skew, like slight skew right, then the mean would be slightly bigger than the median. If there's slight skew left, the mean would be slightly less than the median. And as the skew increases, that difference increases. If they're exactly symmetric, they're equal, the mean and the median. So that's the key. And just the key thing to remember here is if it's symmetry or roughly symmetrical, we can use the mean and standard deviation, which we'll learn to calculate. If there is skewness, you have to use the median and the IQR. So here's a little example. In 2009, the minimum salary for Major League Baseball was $400,000. So most players get close to the league minimum. Superstars will earn far more than that. So there's not a lot of superstars, but the ones that are out there can earn a lot more than $400,000. So the mean, this creates a right skewed distribution. If you picture a lot of values close to 400,000 and very few values as you get further to the right with larger salaries. So it's a right skewed distribution. That lets us know right away that the mean is going to be greater than the median. And in this case, the mean was 3.24 million and the median was only 1.15 million. So if we want to know what a typical baseball player made, it's more like 1.15 million. The few superstars that make a lot of money really pull this average up. So the median provides a better example of what a typical Major League Baseball player earned in 2009. So just a quick reminder that center and spread, median and IQR to go together. We'll use them for a skewed distribution. Remember the IQR is based on all the measures of a box plot, the 5-number summary, and the IQR and the median all go hand in hand. So whenever there's skew, median and IQR. Whenever there's symmetry, mean and standard deviation, or uniform. Okay, so take a look at this curve here, or this histogram, I'm sorry, and picture drawing a curve over it. Think about the shape. Is it symmetrical? Is it uniform? Is it skewed? If so, in which direction? And as a result, what should we use to measure? So pause right now and answer the multiple choice, and then I'll continue and we'll give you the free response. So let's talk about the interquartile range. The interquartile range is a 5-number summary. We always use it when there's skewness. So we break up the data into quarters. So 2 halves, we find where the median is. And then we break up each half into half again. Now we have the data broke up into quarters or quartiles. So find the median. Then look to the left. Find the median of that first half of data. That would be your first quartile. Finally, find the median again of the whole data set. Look to the right of it, all the numbers to the right. Find the median of the data set to the right.
Good morning, Sacred Heart Cathedral.
So the median of that second half of data is quartile 3. Now the interquartile range shows us where the middle 50% of the data is. It's the third quartile minus the first, so it gives us a good sense of where the data really is. So keep in mind when we're talking about this that an outlier would be the maximum or the minimum. So it wouldn't be involved, it wouldn't be Q3 or Q1. So really interquartile range doesn't pay attention to outliers. That's why when there's skew, when there's outliers, it tells us much more useful information, or tends to, because it gives us a better idea of where most of the data is, how spread out the middle 50% of the data is. So this tells me, it's like thinking about the spread of the middle 50% of my data. So for that reason, we use the spread of that middle 50% to define what is an outlier. So we figure out how far quartile 3 and quartile 1 are from each other and multiply it by 1.5. If a value is 1.5 times the IQR above the third quartile or below the first quartile, then it's an outlier. So stop and take a look at that, pause to try to process how we define an outlier. So again, the difference between Q3 and Q1 is my interquartile range, meaning where the middle 50% of my data is. In order to determine what's an outlier, I multiply that by 1.5 and I add it to Q3. Anything greater than that number is an outlier, and then I take the IQR and multiply it by 1.5 and I subtract it from the first quartile. Anything below that is considered an outlier. So we can use all this data and summarize it with a 5-number summary. Our 5 numbers are the smallest observation, the first quartile, the median, the third quartile, and the largest observation. Remember, the median is essentially the second quartile. So a box plot is a nice way to show this information because the first whisker is the minimum, that's not an outlier. The second whisker is Q1. Quarter of my data is right here. The line in the middle of the box is my median. Q3 is right here, my third quartile, and then my maximum that's not an outlier is here. If we had an outlier, we could mark it with an X here. Now this lets me know where the middle 50% of my data is. So it shows me a lot about skew here. We can see we have more data over here, so this looks like it's slightly skewed right. Now you can calculate the 5-number summary on your calculator as well. So you can go into, just like we did in class, stat, edit, put it into L1, then quit, go to stat, 1 var stats, that's 1 variable statistics, and hit enter. 1 variable statistics and then enter the list, L1, if that's where you put it. When you scroll down at the screen it gives you, it'll have the 5-number summary there. So keep that in mind. You should try doing this by hand with the data set I'm going to give you in the free response, and try doing it on your calculator. So again, here's your free response. Please enter this into a list, L1, and then go to Stat, 1var Stats, and then hit L1. You find that in second one. Hit Enter, scroll down, push the down button, and you get a 5-number summary. So you're giving me the 5-number summary for this data set. Finally, the last measure of spread I'm going to talk about quickly is standard deviation. It's the average distance from the mean. So if you thought about each point and how far it is from the mean, what we do is we add those up. So here this means the individual point minus the mean squared. So we do that for every point. This summation symbol means we add all those up for every point. So I take every data point, subtract it from the mean, square it. Then I divide by n minus 1. We'll talk about why we divide by the n is the number of observations. So if I have 7 observations, I divide by 6. That gives me my variance. If I take the square root of variance, it's standard deviation. These are incredibly important to what we'll do all year. We're going to go through and calculate this in class, but take a look at this now. Basically what it tells us is the average distance from the mean. So that's why it's an average just like the mean, so that's why it works well when there's symmetry. So standard deviation is very important. So before we take the square root of this, we call it variance, how much we vary from the mean, and the square root we call standard deviation. So please pause the video, read through Chapter 1, Lesson 3, look at some examples. There's some good examples in the book where they're calculating standard deviation and IQR. And when we come into class, we're going to go over these too. Make sure you look over the summary, and then outline and vocabulary is posted in Schoology.